Hey 5M, this is today's lesson. It is actually 3.9 and you're going to be looking at the interior angles of polygons. You're going to look at triangles closely, you're going to look at quadrilaterals closely and do some investigation. So please follow the directions that are there for you. And also let's work on our noise level once we get to the assignment portion. So once the movie is over and you're supposed to be doing something, please make sure that your voice levels are down so other people that are still working can work and so that you stay focused. Enjoy! Alright, 5M, to get warmed up, go ahead and begin working on math boxes 3.9 on page 91 in your math journal. And after you finish those, you can continue the video. Alright, so we've been talking about all sorts of shapes, and the big group of category of shapes called quadrangles we kind of went over quickly yesterday. I have some statements down below and I want you to see if you can figure these out. Just decide if they are true or false. Okay, we're back. So all squares are parallelograms. Let's take a look at that. So squares are down here, parallelograms are up here. Remember how I talked about how this is kind of like an umbrella? These are all parallelograms underneath of here. Okay, if it fits underneath this loop, it's a parallelogram. Okay. So let's check our answer on that parallelogram. That should be true. Okay, your next one said all rhombuses are rectangles. So here's rhombuses, here's rectangles. This one is actually false, and that is because rectangles have to have 90-degree angles. Rhombuses do not. A kite is a rhombus. So here's our kite over here. Our rhombuses are over here. So they are not the same. If you notice the kite, these bottom two edges are the same and these top two are the same. Therefore, these are not parallel to each other, these lines. So that is false. All quadrangles are parallelograms. So here, quadrangles, are all of them parallelograms? No. This one splits over here, and these are parallelograms. These ones over here are not parallelograms. So that one is false. Trapezoids are not parallelograms. So here's trapezoids. Remember the umbrella of parallelograms is over here. So that is true. And all rhombuses are parallelograms. So here's a rhombus. Are all of them underneath parallelograms? Yes, they are. All right, next up we're going to look at this and we're going to try to put some words in here. Your options here are going to be always, sometimes, or never. Okay, so go ahead and pause the video now and meet back with me in a second. Okay, you must be back. So squares are always rectangles. Okay, to be a rectangles and rhombuses, and you bring them together as a square. To be a rectangle, you have to have two equal sides. Not all four sides equal, but if you look at a square, does it have two equal sides? Yeah, this side is equal to this side, and this side is equal to this side, okay? So always, rhombuses are blank rectangles. Rhombuses, are they rectangles? Sometimes, okay? So sometimes, because if you tilt my rhombus back up so that it looks like a square, it could be a rectangle too. That's kind of a tricky one. Trapezoids are blank rectangles. Trapezoids are never rectangles. Trapezoids are here, rectangles over here. They are not the same. So another note over here is when you bring a rectangle and a rhombus together, that's when you get a square, okay? It's a very special type of rhombus, a very special type of rectangle. A kite is a blank parallelogram. Never, a kite is never a parallelogram. A kite's over here, parallelograms, remember, in this umbrella. And rectangles are blank squares. Rectangles are blank squares. Are rectangles always squares, or rectangles sometimes squares, or never? It is sometimes, okay? Because you can draw a rectangle that has four equal sides, it's still a rectangle, and that would be a square. Those are tricky, so you'll have some time in IXL to practice the quadrangles. Okay, so today, boys and girls, our learning target, our main lesson is I can tell you the sum of the angles of a polygon. Does anybody know what is the sum of the interior angles of a triangle? Any guesses? All right, well, that's what we're going to find out right now. I have a couple of activities to help you figure that out. The first thing I want you to do is draw a triangle on your whiteboard using a straight edge. Make sure they're nice straight lines, don't just sketch it. And then use a protractor to measure all three of its angles, okay? So you need to measure this angle, and this angle, and then add them all up. Okay, you must be back. Hopefully you got an answer that's close to 180. You might be off by a degree or two, but that's okay. Now that was just one triangle. Okay, now we're going to do it with a different kind of triangle. We're going to find the sums of the angles of this triangle. Draw any kind of triangle on your blank sheet of paper right now. When you get done, I want you to go ahead and cut it out and then tear off the three angles of the triangle. So tear off this angle and this angle and this angle. And then try to kind of align them and see what happens. Go ahead and do that now. Okay, when you come back, hopefully you're able to align them kind of like this, okay? So the three angles, when they tear off, they should be really close, if not perfectly make a straight line on the bottom here, okay? Your edges are going to be raggedy, but the bottom should pretty much make a straight line, and that, if it forms a straight line, what is that sum of the angles? Well, a straight line is how many degrees? Hopefully you told me 180 degrees. So no matter what our triangle, we can conclude that the sum of the interior angles of a triangle is always 180 degrees, no matter what the triangle looks like. Okay, so I can add up these three, okay, which I'm guessing is going to be 60, 60, 60, because I know 60 times 3 is 180. Or I could do this one where I've got a 90 and maybe a 45 and a 45 over here. Add those up. So always, no matter what, 180 degrees for a triangle's angles. Okay? Something you're going to remember. You might want to take a screenshot of this. Okay, now we're going to move on to some different shaped polygons. Look at these polygons. What statements can you make about these polygons? Look at the angles. What do you notice about them? Hopefully you're going to notice a few things. Notice this angle though, it's not the normal pentagon we normally see. Instead it has this kind of special angle right here where it goes in, kind of like a cave. And there's a special word that we know about that and it's called concave, okay? So this angle is a concave angle. It goes into the shape. While these ones stick out of the shape and so do these four over here, okay? Along with this one and this one, those are called convex. Okay, concave goes inside like you can go in a cave, and convex, those angles stick out. So I have a little activity for you to do here. You're going to get another blank sheet of paper. I want you to fold it in half. Label one top polygons, the other top not polygons, and then the bottom two sections convex polygons and concave polygons. And go ahead and I want you to try to draw two examples of each. Okay, so we're back here. So these are some examples of some correct answers. There's lots of answers that could go in each box, so just because yours isn't up here, don't think it's not right. If you're not sure, you can definitely have it checked. But polygons, these are just our basic polygons that we see all the time. Not polygons, remember, they can't have openings, they can't cross. They also can't have curved surfaces, so if we look at like this, it's not a polygon, okay? Down here, convex polygons. Now, these ones have all of their angles that stick out. Okay, there's none that shoot in. Okay, and over here are some concave polygons. Believe it or not, this star that we're used to, look at all those angles right there. So I'll kind of put a little star here on the angles that are concave. This one's concave, it goes in. This one, and then all of these on the star where it cuts in like that, those are all concave angles. Okay. All right. Next up. I want you to take another piece of paper, and on that piece of paper I want you to draw, or you can do it with, on a whiteboard, a quadrangle. Okay, so any four-sided figure, also known as a quadrilateral, I want you to measure the angles of your shape and then add them up. to find the sum of the interior angles, kind of like we did the triangle earlier. And I want you to do that twice with two different quadrangles. So you can do like a trapezoid, then a square, or a rectangle, then a parallelogram. You can definitely use your geometry template to help you draw these nicely. Okay, go ahead and do that now. All right, so you're back. So were your answers close to each other? Hopefully, if you did it right, you should be right around like 350, 360, 370, right in there somewhere. Let's do one more thing to try to figure this out, okay? So we know it's around 350, 360, 370. If you didn't get that last time, you probably messed something up. But let's see if, since we know that the sum of angles in a triangle is 180 degrees. That's something we already know. We figured that out. Could we try cutting this quadrangle or quadrilateral into triangles? Now, not lots of little ones, but we're going to actually connect our vertices to cut this into a couple of triangles. So if I cut this right here, what do you notice? How many triangles do I have? Hopefully you notice, obviously, that there are two triangles here. Okay. Well, if this one, interior angles are 180, okay, then this one is 180 inside this triangle, okay. What is that going to be when we put it together? What is 180 plus 180? Okay, we can do the same thing down here. Okay, let's cut this one into two triangles. Same deal. We've got 180 in here. We're going to have 180 degrees in here. And when we add up 180, we are going to get, hopefully you realize it's going to give us a full circle, 360 degrees, because 180 plus 180 is going to give us 360. So quadrangles have the sum of 360. So you might have been around that on our last little experiment, but I'm telling you now that this is a fact. You might want to take a picture of this. 360 degrees is the sum of all the angles of a quadrilateral.